In this video, we'll be looking at how to solve nonlinear equations and systems of equations. Let's first start by solving a simple nonlinear equation. And the tools we're going to be using today are NumPy to create arrays for us, and SciPy.optimize's fsolve capabilities. fsolve will try to drive a function's output down to 0 by changing the arguments of that function. I'll explain that when we get there. Okay, so we're going to go ahead and import NumPy as NP, and we'll go ahead and from SciPy.optimize, we'll import fsolve. So these are the two main tools we'll be using. Now I'm going to start with a very simple example of a very simple equation. Let's look at getting the energy of light. So we'll say def photon energy, and I'm going to add an argument to this function called z. fsolve is going to be updating this z value to try to drive the function's output to 0, or drive what the function returns to values of 0. So for photon energy, let's just go ahead and grab some constants. We have h, Planck's constant, 4.135, e negative 15. So this is the value in electron volts. We then have the speed of light, which is 3 e8, and this is in meters per second. And then let's go ahead and give ourselves a lambda, other words, a wavelength. Let's say our lambda is equal to 525 e negative 9 meters. So that leaves us with the energy. So if you remember the equation, go ahead and write the equation up here. Essentially, the equation for the energy of light says E equals h nu, or E equals h times c over lambda. So we're going to go ahead and use this relationship, but we're going to use our solver to find values of E instead of solving for it explicitly. Again, a trivial situation, but it shows what our solver is doing. So here what we're going to do is we're going to say the output of our function, and I'm choosing the variable named output, and you can choose whatever you want, is going to be equal to h times c over lambda. But you remember, fsolve is going to drive our function's output down to 0. So if e equals hc over lambda, then 0 is equal to hc over lambda minus e. So now we can return this, but you'll notice e isn't defined here. So where do we get our value e? Well, the input to this function, I'm calling it z, and you'll see why when we work with systems of nonlinear equations, why I use a variable name that's not the same as the variable I'm updating. We'll say e is equal to z in the first position. So z is going to essentially be an array with the number of variables we want fsolve to update to try to drive this function's value to 0. So in our case, this is an array of size 1, and in the 0 index of that array is going to be the value we're going to call e. The fsolve is going to be updating constantly. So we're going to return our output. Okay, so now let's go ahead and make a guess. So the optimizer is going to try and find an optimal solution, and we're going to try and give it a good place to start. This guess can be important, especially for more complex equations, because it allows the optimizer to start in a good location that doesn't have too many pitfalls, like asymptotes or other strange behavior in some functions that exist. We should be pretty safe here, though. So I'm going to go ahead and grab a z-guess that's equal to, and I'm going to go ahead and convert this to array. I'm not 100% sure if you need to or not, but we're going to guess that our energy, I don't know, if this is in electron volts, maybe we'll say 1e negative 3, just ballparking. So let's go ahead and run these two lines, get our imports, import NumPy, import fsolve. Let's run our equation, and for fun, let's go ahead and see if I guess my energy has a value of 1e negative 3, what would be the output of photon energy? I'm going to go ahead and put z-guess in there. So it's about 2. Now if I update this, we could show what this solver is going to do. I can update to -6 and see, okay, so it increased by a little bit, maybe -1. So it decreased a little bit more. Maybe we go with just 1E1. Okay, so now we've gone too far in the opposite direction. And you can see we can slowly narrow in on what the actual solution might be. Maybe we try 2. And we got even closer there. Now, before we get to the final solution, let's go ahead and see fsolve do this. So we'll say our final value z is going to be fsolve's output. When I give fsolve access to the function, notice I don't give the argument, that we want it to drive the output down to 0, and a guess, and a guess on what values might drive that output to 0. So we saw 2 did a very good job of getting us close to 0. So we'll start fsolve at that location, and it'll update these values until it finds the correct set of values that makes photon energy at z equal to 0. So let's go ahead and run this. And so we can see fsolve has finished running, and it gives us a value of z equals 2.3628. Now we can finally verify, did that work? We'll see yes. In fact, the energy in electron volts, if lambda comes in at 525 meters, or sorry, 525 e-9 meters, is 2.36 electron volts. So fsolve was able to take the equation we gave it and our guess and update the variables inside of that equation, which were defined by argument z, such that the output had a value of 0. Now, fsolve can fail. If you give it a bad guess, it may fail to find a solution, and that can happen for 2 reasons. One, your tolerance is too high, meaning it thought it found a a value close enough to 0, but it didn't in fact find a valid root. Or the other is it reaches a maximum number of iterations, meaning it searched for too long, finding nothing within the tolerance you dictated. Your best bet for fixing this is updating your guess or updating the method in which you use to solve. Now let's look at a system of nonlinear equations. So we're going to step the game up a little bit. I'm going to propose that you have this system of equations you want to work with. If you want to learn all about this, go ahead and visit this website here. They have great videos and great instructions on how this works. But let's say you have this system of nonlinear equations. Notice the squareds in here. So this cannot be solved using a straightforward linear algebra technique. Let's go ahead and outline how we might be able to solve this. Let's start by defining a function whose output we want to drive to 0. Now because we have 3 equations, this function is going to have 3 outputs whose values we'll want to drive to 0. And fsolve will try to find the correct value for all 3 variables such that this is satisfied. So I'm going to go ahead and say def my function. We're going to give it a value z. Now here, we're going to say x is equal to z0, y is equal to z1, and z, x, y, and w is equal to z2. So what we have here is we have this input array z, and the variables we want to update to drive our function's output down to 0 are stored in this variable z. And then we can define the variable named x as one of those locations in this z array. Okay, so we know that we wanted to drive these 3 equations to a value of 0. So let's go ahead and rewrite these equations so that can be true. So we'll say f1, we'll start with 0 because this is Python, equals x squared plus y squared minus 20. We'll say f1 equals y minus x squared. So again, we're making it so that this is equal to a value of 0. So if we pull x squared over here, this is also equal to a value of 0. And then finally, f2 equals w plus 5 minus x times y. Okay, and I'm going to go ahead and store those within an array. So I'll say np.array, and we'll call this f. np.array is going to be equal to f0, f1, and f2. And we'll have our function return f. So if we look at how this function is going to behave, it'll take in an array z, which has x, y, and w on it, or which is assigned to x, y, and w. It'll build functions f0, f1, and f2, all of which should eventually take a value of 0 if we have the correct x, y's, and w's. And it'll return these three functions. So f essentially is an iterable of size 3. And now we're going to let fsolve try to take care of this. So let's go ahead and give a zguess again. And we'll say zguess is equal to np.array of, let's go with 1, 1, 1. And then we'll say z is equal to fsolve. And we'll give it my function and our zguess. Again, notice my function, we're not actually putting in any arguments. And then let's go ahead and run this. So I'm going to highlight this function and hit F9 since we're in Spider. Zguess is going to be np.array, so we'll define that over here. And notice we already have a z, that was from the previous question. Let's see what it updates to. Z is now a size 3 array with values 2, 4, and 3. And so 2 squared plus 4 squared is equal to 4 plus 16. Minus 20 does in fact equal 0, so that is those are correct values to satisfy this equation. And then we can go here and we can say 4 minus 2 squared, that does in fact equal 0. And then finally we can say 3 plus 5, which is 8, minus 2 times 4, which is 8, equals 0. So we see fsolve has indeed produced the correct result for our equation. Now, one final thing that's always been a source of confusion for me is you can also add arguments to my function. So let's say we don't always want this value to be 20. Let's say we want this value to be variable. Now, this is a terrible name, but I'm going to go with it. Well, if we wanted to input that to our function as well, how do we do that? Well, fsolve, we can go ahead and access its help function. Fsolve gives us a nice way of inputting our function's arguments using the args keyword. So if we come down here, any extra arguments to the function, this is optional, and it needs to be input as a tuple. So we can grab args as a tuple. We will input a value we want for variable. So if we input 20, let's go ahead and redefine my function. We should get the same value of z. But what if we change it to 25? We now get updated values that reflects the fact that this argument to the function has been updated from 20 to 25, and we need new values for x, y, and z, or sorry, x, y, and w, that satisfy these new equations. So hopefully that gets you very far with using these nonlinear solvers. And again, remember, oftentimes the guess is extremely important. And one thing I didn't cover is there are different types of methods you can use for many of these different solvers. I think fsolve uses a fixed type of method for solving. But when we talk about minimize in the next video, you'll see there's many different ways we can get to the correct solution. Okay, good luck.